In this video, we are going to understand how frame switching happens in switch.
A switch is a layer 2 device that forwards traffic based on the MAC address table. The switch builds and maintains its MAC table by matching the destination MAC addresses with the port that is used to connect to that particular node. As you probably recall, each Ethernet frame contains a source and destination MAC address. So, when a switch receives an incoming frame, it compares the destination MAC address frame header to the list of addresses in its MAC table. Switches then use the MAC addresses as they decide whether to filter, forward, or flood frames. So, what kind of information can you find in a MAC table? You can find the mapping between the MAC address and the port to which the certain MAC address is attached. If the destination MAC address in the received Ethernet frame matches the entry in the MAC address table, the switch then forwards the frame to the corresponding port only. But how can a switch learn the MAC addresses, meaning which MAC address is attached to which port? The switch creates and maintains a table using the source MAC addresses of incoming frames and the port numbers through which the frames entered the switch. When a switch doesn't know an address, it learns the network topology, and it does this by analyzing the source address of incoming frames from all attached networks. If you take a look at our example, let's say that PCA sends a frame to PCB. The switch receives a frame from PCA on port 1, and then the switch can now enter this information into its MAC table. And it would be the MAC of PCA is accessible via port 1. The switch checks the MAC address table for the destination MAC address of PCB. PCB hasn't sent any frames yet, so there is no entry for the MAC address of PCB in the MAC table. Because the destination MAC address is not known, the switch floods the frame to all ports except on the port which the frame was received. And this is the default behavior, and this means that the switch sends the frames out ports 2 and 3. The destination device, which is PCB, replies with a unicast frame addressed to PCA. And as you can see, PCB sends a frame with a source MAC address set to MAC address of PCB and the destination MAC address set to the MAC address of PCA. Now that the switch has the MAC address of PCB, it can update its MAC address table, and that says the MAC address table of PCB is accessible via port 3. But remember, the destination MAC address of the frame is set to the MAC address of PCA. So what will the switch do now? Well, the switch will perform a MAC address table lookup to verify this MAC address in its MAC address table. It can see that the destination MAC address of PCA is associated with port 1. So the switch will forward the frame to port 1 only. Now the switch can forward frames between PCA and PCB without flooding because it has entries in its MAC address table that identify the associated port.